We're moving on here to 3.3 building block, which we're going to focus on horizontal asymptotes and end behavior of rational functions. We talked about rational functions last week. We talked about finding vertical asymptotes, finding holes, finding zeros or x-intercepts. Okay, so now we're going to talk about finding horizontal asymptotes, because we have to know where the horizontal asymptote is to be able to give the end behavior. Because the end behavior is what the graph is doing on the left and right. And if there's a horizontal asymptote, that's what the graph is going to be approaching. It's not going to go up forever or down forever always, like we just said with polynomials. With rationals, if there's a horizontal asymptote, that's what we're approaching. Okay, so we need to understand how to find those horizontal asymptotes so that we can give the end behavior correctly. So here is a list. There's 8 functions here in this table. They're all rational functions, but each of them have a different relationship between degree of the numerator and degree of the denominator. So I'm going to highlight to color code this. So we're going to find the degree of the numerator, because there's a function in the numerator, and then there's a separate function in the denominator. Okay, and I'm going to find that. And then I'm looking at their relationship between those two. And based on that relationship, I'm going to categorize them into 3 groups. Okay, so let me look at the first one with you. So what is the degree of the denominator here in a of x? 2. Okay, what is the degree of the numerator function? Also 2. So it says to look at the relationship between them. So how are those related, 2 and 2? They're the same. So I'm going to put that in one group when the degrees are the same. Does that make sense? So, and you don't have to write the whole thing out. You can just write a of x, because they all have a different name. So I'm going to put in group 1, I'm going to put a of x. And then with it, I'll put any others that have that same relationship where those degrees are equal. Okay, so this one is the one where I'm writing the degrees are equal. Does that make sense? And then you'll have 2 other groups. So I'm going to give y'all a couple minutes to try and identify all of the degrees of the numerators and denominators and categorize them into 3 different groups. And then we're going to talk about it. And if you need to switch something around, you can. So hopefully you're writing in pencil in case you need to erase something. Okay, but I'm going to give you a minute to identify those degrees and categorize. And then we'll talk about it and look at it together. All right, so let's take a look at what y'all categorize these as. So first, I'm going to go through and do my highlighting. Okay, so for b of x, what is the degree in the numerator? 2. So I don't have to switch back and forth between colors. So I'm just going to do all the numerators first. So in c of x, what's the degree in the numerator? In the numerator? Not 0, a 1. If nothing is written, it's an understood 1. Okay? The 0 would be the constant, like 9 is 9x to the 0. So you don't even see the x. Okay, so the highest degree here is 1. Okay, what about in d of x? In the numerator. 1 also. Good. Okay, what about in e of x? The degree of the numerator. In f of x? 1 again. And in g of x? 2. H of x? Good. So these were all actually in descending order. So they all actually were the lead term, which was nice. Okay, now let's look at the denominators. Okay. Oh, thank you. All right, in the b of x, what's the degree of the denominator? That would be the understood 1. Okay, and in c of x? Good. In d of x? E of x? That 1. And in f of x? And in g of x? And h of x? Understood 1. Okay, so that's how I would categorize all of those. So we will pick this up here tomorrow.